Hello students, welcome back to this bridge course session from Vedantu. We are continuing with our bridge course on chapter Mole Concept, right? So what we have seen so far in this series, if you have not seen the previous videos, I would love you to go through them. This is Abhilash here, your master teacher in chemistry. What we have already done in like 2 videos in this chapter is we looked at the definition, basic definition of mole, molar volumes and applications, Avogadro's hypothesis, Gay-Lussac's law of combining volumes and so on. Then in the second video, we looked at concepts related to density, average molecular mass and empirical formula. And in today's video, we are going to look at a very important part of the chapter called mass, volume and mole analysis. So when you have a balanced chemical equation, based on that equation, how do you compare the masses of different substances, reactants and products? How do you compare if gases are involved? How do you compare the volumes? And how can you like probably speak in terms of moles, number of moles, comparing in terms of number of moles is what we are going to do today, right? So this is a very important part of the very important part of the chapter, because this is like primarily the aim of the chapter, to analyze a balanced chemical equation, use stoichiometry basically, and relate the weight of reactants and products or volume of reactants and products and so on, right? So what are the three parts here? Mass analysis, mass volume analysis and mole analysis, right? So let's look at the first slide, right? So what exactly is a balanced equation? A balanced chemical equation, a general balanced chemical equation looks like this: AA plus BB giving you CC plus DD, where the small a, small b, small c and small d are called the stoichiometric coefficients. These are the numbers that you use to balance the reaction. Basically, in a balanced chemical reaction, mass is conserved, number of atoms of different elements have to be conserved, the substances that are taken should be in their standard states. Normally you would also see that the state of the substance is also given, like gaseous state hai ya fir solution hai ya fir pure liquid hai, solid hai, that should also be given. Okay, although yes, for this particular chapter we don't really need the state as much, because I mean usse related energy wali concepts jo hai, there it becomes more important. As far as we are concerned, as long as we have a balanced chemical equation, we should be able to uh, speak about the relationship between reactants and products in terms of weight or volume or moles, right? So that is the aim of our today's session, right? So what you can read, like what you should read in your head when you see a balanced chemical equation like this is: a moles of a, small a moles of capital A, the substance A, reacts with small b moles of B to give you small c moles of C and small d moles of D, right? Like for example, we are going to look at this example to drive the point home. Okay, this one particular example is something we will look at in different ways, in terms of mass analysis, या फिर in terms of volume analysis, या फिर in terms of mole analysis. So that based on the question we can see which one to use. ठीक है, mass analysis use करना है या volume analysis use करना है, mole analysis use करना है, we should be able to understand that, right? So when I have a reaction like this, let's say 4Fe in solid state combines with 3 oxygen in gas phase to give you 2 Fe2O3 in solid phase, right? So this is a balanced chemical equation that is given to us. States are mentioned, substances are written in their standard states. For example, यहाँ पे मैं ये नहीं लिखूंगा 6O. That doesn't make any sense, right? Oxygen अगर आप use कर रहे हो in its standard form, तो आप O2 के form में ही इसको आप use करोगे, right? So this reaction, when I see this, what I can interpret is 4 moles of Fe combines with 3 moles of O2 to give you 2 moles of Fe2O3, right? तो अब ये हो गया moles के terms में comparison. weight के terms में compare करना है तो I can say 4 into 56 gram Fe, atomic mass जो है ion का 56 है, तो 4 into 56, 224 grams of Fe combines with 3 into 32 यानी कि 96 grams of oxygen, या फिर वॉल्यूम के टर्म्स में 3 into 22.4 67.2 liters at STP, ठीक है, to give 2 moles of Fe2O3. Fe2O3 का molecular weight is 160, right? Fe2O3 मतलब 112 plus 48 160 into 2 मतलब आपके पास 320 grams of product will be obtained. Mass is conserved, 224 plus 96 is 320. बाकी वॉल्यूम कंजर्वेशन वगैरह कुछ होता नहीं है यहाँ पे। वॉल्यूम के टर्म्स में अगर क्वेश्चन आ गया तो यू विल हैव टू हैंडल इट यूजिंग कॉमन सेंस, राइट? Now let's look at this mass analysis, uh, volume analysis, and mole analysis. Where do you use it, right? So let's say, what is the weight of Fe? What weight of Fe will be required? Same question दिया हुआ है, same example के terms में we are uh, solving in different angles, right? So first question is, what weight of Fe will be required to produce 96 grams of Fe2O3? ठीक है, तो यहाँ पे मास एनालिसिस कैन बी यूज्ड। मोल के टर्म्स में आप हमेशा ही कर सकते हो, मोल एनालिसिस कैन बी यूज्ड एनी टाइम, बट मास के टर्म्स में अगर आपको प्योरली करना है तो व्हाट विल यू डू? ठीक है, मास एनालिसिस इज कॉमन सेंस, मास एनालिसिस इज जस्ट यूनिटरी मेथड। ठीक है, यूनिटरी मेथड क्या है, आई विल एक्सप्लेन इट यू। ठीक है, 224 grams of Fe gives 320 grams of Fe2O3. This we have already seen, right? 224 grams of Fe gives 320 grams of Fe2O3. So if you want to get 96 grams, then the weight of Fe needed will be how much is the question. Okay. So unitary method is this: 224 gives 320. What weight will give me 96? That is the question. Cross multiply, you will get question mark is equal to 96 into 224 divided by 320. Question mark into 320 should be equal to 224 into 96. तो आपके पास आएगा question mark is equal to 224 into 96 divided by 320, which is 67.2 grams. ठीक है, 320 32 into 3 is 96 और 10 बचेगा, तो 22.4 into 3 is 67.2 grams. ठीक है, तो दिस इज व्हाट यू कॉल एज यूनिटरी मेथड। बेसिकली अगर आपको कोई बोले कि 5 एप्पल्स का कॉस्ट है बॉस 120, राइट, तो आपके पास 10 एप्पल आप लोगे या फिर 25 एप्पल आप लोगे तो क्या कॉस्ट पड़ेगा, ऐसा टाइप का चीज यूनिटरी मेथड है, राइट? तो wherever there is linear relationship between two things, you can use this unitary method. तो I'll do is, okay, 5 apples का 120, 25 का क्या होगा, क्रॉस मल्टीप्लाई, I'll get question mark is equal to 25 into 120 divided by 5, which is equal to 5 into 120, which is 600 rupees. ठीक है, वैसे टाइप का है your, wherever there is linear relationship between two things, you can use this unitary method, which is just linearity को आप यूज कर रहे हो, राइट? तो यहाँ पे 224 grams of Fe gives 320 grams of the oxide. So what weight of Fe will give me 96 grams of oxide? Cross multiply, you will get this weight to be equal to 67.2 grams. ठीक है, दिस इज लाइक यूनिटरी मेथड बोलो, या फिर आप ऐसे बोल सकते हो कि यू आर यूजिंग व्हाट यू कॉल एज द लॉ ऑफ कांस्टेंट कंपोजिशन। ठीक है, weight ratio of Fe and Fe2O3 will always be the same, 224 is to 320. That is the idea we are using here. This is what you call as mass analysis. We are just comparing masses of reactants and products based on what we can say about their ratio in the balanced chemical equation. ठीक है, तो दिस वाज बेसिक मास एनालिसिस। लेट्स लुक एट वॉल्यूम एनालिसिस बेस्ड। ठीक है, तो वॉल्यूम एनालिसिस भी होता है जहां पे आप सीधा गैसियस रिएक्टेंट्स और प्रोडक्ट्स अगर है तो वो आप गेलुसैक्स लॉ यूज करिए। फॉर एग्जांपल लेट्स से N2 + 3H2 गिविंग यू 2NH3, ऐसे टाइप का एक रिएक्शन है मान लो। ठीक है, तो ये रिएक्शन में यू कैन से Gay-Lussac's law says that volume ratio will be a simple whole number ratio when gases combine with each other. Their volumes bear a simple whole number ratio to one another, which is same as ratio of their coefficients. ये है Gay-Lussac's law। इनका वॉल्यूम रेशियो एक सिंपल रेशियो होगा और वो जो रेशियो है वो उनका कोएफिशिएंट्स का रेशियो होगा। ये है अपना Gay-Lussac's law। तो इफ somebody says फॉर एग्जांपल कि इसका 21 लीटर कंज्यूम हो गया, तो इसका कितना कंज्यूम हुआ, इसका कितना बना, if that is the question, so what I'll say is, okay, volume of N2 divided by volume of hydrogen should be equal to 1/3। ये Gay-Lussac's law of combining volume से आया। तो आपके पास volume of N2 आएगा volume of H2 into 1/3, राइट, क्रॉस मल्टीप्लाई किया तो इससे आएगा volume of N2 is equal to 1/3 times 21, यानी कि 21/3 which is 7 liters। ठीक है, सिमिलरली अगर आपको वॉल्यूम ऑफ अमोनिया चाहिए तो आप बोलोगे वॉल्यूम ऑफ H2 वॉल्यूम ऑफ NH3 डिवाइडेड बाय वॉल्यूम ऑफ H2 शुड बी इक्वल टू 2/3। क्रॉस मल्टीप्लाई करो, आपको मिलेगा वॉल्यूम ऑफ NH3 इक्वल टू 2/3 टाइम्स 21 which is equal to 14 liters। तो वॉल्यूम रेशियो 7:21:14, यानी कि 1:3:2 2 आएगा. This is volume analysis, right? Gay-Lussac's law of combining volumes use करके directly comparing the volumes of gases, different gases involved. That is what you call as Gay-Lussac's law of combining volumes. But कंपलसरी नहीं है कि आपको हमेशा वॉल्यूम वॉल्यूम एनालिसिस टाइप्स का हो. ये क्वेश्चन फॉर एग्जांपल यहाँ पे जो है दैट इज मास वॉल्यूम एनालिसिस. ठीक है, लेट्स लुक एट द क्वेश्चन. व्हाट वॉल्यूम ऑफ ऑक्सीजन एट एसटीपी विल बी रिक्वायर्ड टू रिएक्ट विद 56 ग्राम्स ऑफ Fe. ठीक है, तो यहाँ पे what we'll say is okay, looking in the balance reaction I can see कि 4 into 56 grams of Fe is reacting with 3 moles of O2 यानी कि 3 into 22.4 liters of oxygen. ठीक है, तो 3 into 22.4 liters of oxygen is combining with 224 grams of Fe. Then what volume of oxygen will combine with 56 gram of Fe? Again linearity है यहाँ पे, wrote both of these, cross multiply, so I'll get volume of oxygen question mark is equal to 56 into 3 into 22.4 divided by 224. तो ये आया 56 into 3 into 22.4 divided by 224. ये आएगा आपके पास 16.8 liters. समझ में आया? So you can compare masses, volumes, volumes to volumes, mass to volumes, anything. ठीक है, mole analysis can be applied everywhere. You will see that very soon in the next example. But yeah, point is आपके पास अगर balanced chemical equation है so you can compare masses to volumes or masses to mass and so on, because they will always have a linearity. They will have a fixed ratio between them. Right? तो यहाँ पे specifically I said 4 into 56 gram Fe यानी कि 224 grams of Fe combines with 3 moles of oxygen, मतलब 3 into 22.4 liters of oxygen. So what volume of oxygen is going to combine with 56 gram was my question. Cross multiply किया, volume of oxygen आया 16.8 liters. This is simple volume analysis, right? Mass volume analysis भी बोल सकते हो इसको. Let's look at the next question. Okay, mole analysis के terms में है यहाँ पे. How many moles of oxygen will be required to produce 8 moles of Fe2O3? यहाँ पे स्पेसिफिकली मैंने मोल्स के टर्म्स में क्वेश्चन बनाया है, बट कंपलसरी नहीं. कुछ भी मिले आपको, वेट वॉल्यूम कुछ भी मिले, यू नो हाउ टू फाइंड नंबर ऑफ मोल्स फर्स्ट, राइट? तो यू नो नंबर ऑफ मोल्स इज इक्वल टू वेट डिवाइडेड बाय मॉलिक्यूलर वेट, या फिर यू कैन से दैट दिस इज इक्वल टू वॉल्यूम डिवाइडेड बाय 22.4 लीटर्स, राइट? अगर वॉल्यूम लीटर्स में है तो डिवाइडेड बाय 22.4, ये दोनों से आप नंबर ऑफ मोल्स निकाल सकते हो. तो इवन इफ इट इज नॉट डायरेक्टली मोल्स बेस्ड, यहाँ पे मैंने दिया स्पेसिफिकली हाउ मेनी मोल्स ऑफ ऑक्सीजन विल बी रिक्वायर्ड टू प्रोड्यूस 8 मोल्स ऑफ Fe2O3, बट ये कंपलसरी नहीं है. आपको नंबर ऑफ मोल्स की जगह वेट भी दे सकते हैं, तब भी आप ये सेम एनालिसिस यूज कर सकते हो. फाइंड नंबर ऑफ मोल्स फर्स्ट, राइट? तो हियर based on the balanced equation, what I can see is 3 moles of oxygen is giving me 2 moles of Fe2O3, right? 3 moles of oxygen gives me 2 moles of Fe2O3. तो 8 moles के लिए कितना moles, that is the question. ठीक है, so what if we write 3 moles of oxygen gives 2 moles of Fe2O3, then how many moles of oxygen will be required to get 8 moles of Fe2O3? Cross multiply, you will get question mark is equal to 3 into 8 divided by 2. 3 into 8 divided by 2 मतलब 12 moles. So 12 moles of oxygen will be required to react with 8 moles of 12 moles of oxygen will be required to produce 8 moles of your Fe2O3, right? So this is of course a balanced chemical equation where directly number of moles we could relate. They had given us number of moles, they had asked us about number of moles, so we can compare them directly. Now this is one way of doing it. The other thingy that we can use is what we call as mole analysis equation. Okay? Mole analysis equation क्या है? Mole analysis equation is in a general reaction like this, AA plus BB giving you CC plus DD. इसमें number of moles of A consumed divided by A will be equal to number of moles of B consumed divided by B, which will be equal to number of moles of C produced divided by small c, and number of moles of D produced divided by small d. ठीक है, This is called mole analysis equation. आपको balanced chemical equation मिलते ही आप ये लिख सकते हो. ठीक है, ये कहां से आया? I will tell you that in an example. But yeah, this is what you have to remember. Number of moles of A consumed divided by small a will be equal to number of moles of B consumed divided by small b should be equal to number of moles of C by small c. And like for example आपके पास N2 plus 3H2 वही वाला एग्जाम्पल की बात करें, giving you 2NH3, इसमें आप बोल सकते हो number of moles of nitrogen divided by 1, जो भी number of moles of nitrogen by 1 है जो consume हो गया, equal to number of moles of H2 consumed divided by 3 will be equal to number of moles of ammonia produced divided by 2. Because mole ratio will be fixed. 1:3 ratio में नाइट्रोजन हाइड्रोजन गायब होगा, डबल 2 मतलब क्या बोलूं 1:2 रेशियो होगा आपका नाइट्रोजन टू अमोनिया का प्रोडक्शन, राइट? तो अब इसके लिए लेट्स लुक एट अ रैंडम एग्जांपल एंड सी हाउ दिस मोल एनालिसिस इक्वेशन कम्स अबाउट. ठीक है, लेट्स से कि आपके पास एक इक्वेशन है 2AlOH thrice plus 3H2SO4 giving you Al2SO4 thrice plus 6H2. लेट्स से कि ये एक बैलेंस्ड केमिकल इक्वेशन रैंडम सा आपके पास पड़ा हुआ है. ठीक है, when I am seeing this equation, how can I read it? कि 2 मोल एल्यूमिनियम हाइड्रोक्साइड 3 मोल H2SO4 के साथ रिएक्ट करेगा हर बार और 1 मोल एल्यूमिनियम सल्फेट बनेगा और 6 मोल्स H2O बनेगा. हर बार जब भी रिएक्शन होता है 2 मोल इसका गायब होगा, मतलब हर बार नहीं बोल सकते, 1 मोल टाइम्स जब रिएक्शन होगा 6 into 10 to power 23 टाइम्स जब ये रिएक्शन होगा तो 2 moles of aluminum hydroxide is consumed, 3 moles of H2SO4 is consumed, 1 mole of the salt is produced and 6 moles of water is produced. Now let's just say कि कोई अगर आपको बोले कि इसका 48 moles बना पानी का, right? So if somebody tells you that 48 moles of water is produced, then can you tell me how many times did the reaction take place? 8. Obvious, right? Every time 6 moles of water is produced, and if 48 moles are produced, this means that the reaction happened 8 times, right? तो अगर 8 बार रिएक्शन हुआ तो एल्यूमिनियम सल्फेट के कितने मोल्स बने होंगे? 8 मोल्स. कॉमन सेंस, हर बार 1 मोल बनता है तो 8 बार में क्या होगा? 8 मोल बनेगा. हर बार 3 मोल H2SO4 कंज्यूम होता है तो 8 बार में कितना कंज्यूम हुआ होगा? 24 मोल्स विल बी कंज्यूम्ड. हर बार 2 मोल एल्यूमिनियम हाइड्रोक्साइड कंज्यूम होगा तो 8 बार में कितना होगा? 16 मोल्स ऑफ एल्यूमिनियम हाइड्रोक्साइड विल बी कंज्यूम्ड, राइट? तो ये based on number of moles of one of these substances, the number of moles of all others can be obtained because their ratio has to be the same, right? तो आपके पास H2O का 6 moles बनता है हर बार, 48 बना टोटल, तो I know कि the reaction took place 8 times, and if reaction took place 8 times, 8 मोल एल्यूमिनियम सल्फेट बना होगा, 24 मोल H2SO4 कंज्यूम हुआ होगा और 16 मोल एल्यूमिनियम हाइड्रोक्साइड कंज्यूम हुआ होगा, right? Now look at this 16, this is your n number of moles, right? So number of times की बात करें, let's divide by this coefficient 16 divided by 2 या फिर 24 divided by 3 या फिर 8 divided by 1 या फिर 48 divided by 6. What do you see? All of these are equal and all of these are equal to 8, which is the number of times that the reaction has taken place या फिर number of moles of times that the reaction has taken place, right? That is why we write number of moles of any substance divided by its own coefficient will be equal for all of these substances that are involved in the reaction. The number of moles of A consumed by A, small a, should be equal to number of moles of B consumed divided by small b, should be equal to number of moles of C consumed divided by small c, should be equal to number of moles of C produced by small c, and number of moles of D produced divided by small d, right? तो यहाँ पे ये एक की भी नंबर ऑफ मोल्स अगर मालूम है तो बाकी सबके नंबर ऑफ मोल्स आपको मिल जाएगा. दैट इज योर मोल एनालिसिस, राइट? तो ऑलवेज रिमेंबर दिस. For a general reaction, you will be saying that for a general reaction like this, you can say Na by A equal to Nb by B equal to Nc by C equal to Nd by D. बैलेंस केमिकल इक्वेशन मिलते ही आप ये लिख दो. और ये नंबर ऑफ मोल्स, अब स्मॉल a, स्मॉल b, स्मॉल c, स्मॉल d तो आपको मालूम है क्योंकि बैलेंस केमिकल इक्वेशन इज गिवन टू यू, राइट? सो इफ स्मॉल a, स्मॉल b, स्मॉल c and small d are known to you because you already know the balanced equation. If you know one of these न्यूमरेटर्स में से कोई भी एक अगर मिल जाए बाकी सब मिल जाएगा. जैसे यहाँ पे वो H2O वाले केस में आपके पास H2O के नंबर ऑफ मोल्स थे, बाकी सबके नंबर ऑफ मोल्स मिल गए, right? So you just knew the number of moles of H2O to be 48. Based on that, you found out the number of moles of aluminum sulfate produced number of moles of H2SO4 consumed and number of moles of aluminum hydroxide consumed, right? So this is basic balanced what do you call as a mole analysis of balanced chemical equation. Let's look at one question to just wrap up this thing and understand this better, right? Propane gas burns in air according to formula C3H8 plus 5O2 giving you 3CO2 plus 4H2. Okay. What volume of air at STP containing 20% by volume of oxygen will be required to completely burn 13.2 grams of propane gas? Okay. So what do you know? You are given that 13.2 grams of propane gas is completely burnt, right? तो आप नंबर ऑफ मोल्स ऑफ प्रोपेन तो निकाल ही सकते हो. नंबर ऑफ मोल्स ऑफ प्रोपेन आएगा आपके पास 13.2 डिवाइड बाय प्रोपेन है C3H8 मॉलिक्यूलर वेट आएगा 36 प्लस 8 मतलब 44. तो ये आया आपके पास 13.2 डिवाइड बाय 44 which is equal to 0.3. So you know the number of moles of propane. Now what is your mole analysis equation? Mole analysis equation is number of moles of propane divided by 1 should be equal to number of moles of O2 divided by 5 should be equal to number of moles of CO2 divided by 3 should be equal to number of moles of H2O divided by 4. Right? तो इसमें से what do we know this time? Number of moles of propane is 0.3. ठीक है, तो 0.3 divided by 1 should be equal to number of moles of O2 by 5, number of moles of CO2 by 3 and number of moles of H2O divided by 4. इससे एक एक करके नंबर ऑफ मोल्स निकालो. सबसे पहले आएगा नंबर ऑफ मोल्स ऑफ O2 इज इक्वल टू 5 इंटू 0.3 क्रॉस मल्टीप्लाई किया तो 5 इंटू 0.3 डिवाइडेड बाय 1 यानी कि 1.5. नंबर ऑफ मोल्स ऑफ CO2 आएगा आपके पास 3 इंटू 0.3 डिवाइडेड बाय 1 यानी कि 0.9 और नंबर ऑफ मोल्स ऑफ H2 आएगा. इन दोनों को इक्वेट करोगे, फर्स्ट और लास्ट को इक्वेट करोगे तो इससे आएगा नंबर ऑफ मोल्स ऑफ प्रोपेन इंटू 4 डिवाइडेड बाय 1 यानी कि नंबर ऑफ मोल्स ऑफ H2 इज 1.2. So what is asked? What volume of air at STP containing 20% oxygen by volume? तो एयर में पूरा ऑक्सीजन नहीं, ऑक्सीजन के मुझे चाहिए 1.5 मोल्स. तो ऑक्सीजन का वॉल्यूम क्या होगा? वॉल्यूम ऑफ ऑक्सीजन रिक्वायर्ड विल बी 1.5 into 22.4 which is 33.6 liters, right? This is the volume of oxygen that I need, but this is the volume of pure oxygen. What is the volume of air is what they have asked you. So what do you know? Volume of oxygen is 20% of volume of air. Okay, so what did I do? I converted this statement, English verbal statement, into mathematics. Volume of oxygen is 20% of volume of air. तो volume of air आएगा आपके पास 100 by 20 into 33.6. 100 by 20 मतलब 5 into 33.6. ये आएगा आपके पास 5 into 33 is 165 plus 3 is 168. The volume of air required will be 168 liters. So when you have 168 liters of air, 20% of that is oxygen. So 20% of that is 33.6 liters, which is 1.5 moles, which we require. Right? Now, what they have asked you in B is, what will be the volume of CO2 produced? Okay? Again, number of moles of CO2 will get 0.9. So you can just say 0.9 into volume of CO2 at STP will be equal to 0.9 into 22.4, which is 224 22.4 minus 2.24 यानी कि आएगा आपके पास 20.16 लीटर. ठीक है, 22.4 minus 2.24 which is 20.16 liters. Now what will be the weight of water produced? Water produced के लिए number of moles we know 1.2 है, तो weight of H2O will be 1.2 into molecular weight. Molecular weight of water is 18, so 1.2 into 18 is 18 plus 3.6 which is 21.6 grams. Right? So what did we do here? We used what you call as mole analysis. Mole analysis का equation ये जो equation है, number of moles of propane by 1 equal to number of moles of O2 by 5 should be equal to number of moles of CO2 produced by 3 should be equal to number of moles of H2 produced divided by 4. ये relate किया. इसमें से we knew the number of moles of propane because we were given the weight of propane as 13.2 grams. So 13.2 divided by 44 करके वी गॉट द नंबर ऑफ मोल्स ऑफ प्रोपेन एज 0.3. तो एक न्यूमरेटर मिल गया, कोई भी एक न्यूमरेटर मिल गया, बाकी सारे मिल जाएंगे. तो आई गॉट नंबर ऑफ मोल्स ऑफ O2 बाय रिलेटिंग दीज टू. तो उससे आया नंबर ऑफ मोल्स ऑफ O2 इज इक्वल टू 5 into 0.3 by 1 which is equal to 1.5. Then we related these two, first and third. तो ये आया नंबर ऑफ मोल्स ऑफ प्रोपेन 0.3 divided by 1 is number of moles of CO2 by 3. तो नंबर ऑफ मोल्स ऑफ CO2 आया 0.3 into 3 which is 0.9. Then we compared the first and the last one. So number of moles of propane divided by 1 is number of moles of H2O by 4. Number of moles of H2O आया 4 into 0.3 1.2. Right? फिर ऑक्सीजन का वॉल्यूम निकाला 33.6 लीटर्स है, बट दे सेड it is only 20%, right? So air में only 20% is oxygen. So 20% of air, 20% into volume of air should be equal to volume of oxygen. इससे volume of air आया 168 liters. Number of moles of CO2 we knew is 0.9. Volume पूछा हुआ था, तो volume of CO2 we said 0.9 into 22.4 at STP. तो यह आया 20.16 liters. और नंबर ऑफ मोल्स ऑफ वाटर मालूम था 1.2 है, तो वेट ऑफ वाटर आया आपके पास 1.2 नंबर ऑफ मोल्स इनटू मॉलिक्यूलर वेट इक्वल टू 21.6 ग्राम. राइट? so this is basic mole analysis. Basic mole analysis is something that you can use way more effectively, if you know, because this is something that you should know if you want to look at other chapters also. As I told you before, ये mole analysis वाला जो angle है, this will be utilized almost everywhere, right? Ionic equilibrium हो, चाहे chemical equilibrium हो, या फिर kinetics हो, everywhere you should be able to understand this mole analysis का equation really well, right? So I hope you understand what was given here. Mole analysis वाला equation ये रहा, और एक के number of moles मालूम थे तो बाकी सबके मिल गए, तो you should be able to get volume or weight as the case might be, right? So I prefer mole analysis. आप mass analysis से भी कर सकते थे, वॉल्यूम एनालिसिस, मास वॉल्यूम एनालिसिस वगैरह से भी कर सकते थे. मास वॉल्यूम एनालिसिस से क्या करते, आप यहाँ पे देखते कि ओके ऑक्सीजन के फॉर एग्जांपल कार्बन डाइऑक्साइड का वॉल्यूम अगर कैलकुलेट करना हो तो मैं बोलूंगा 44 ग्राम. मास वॉल्यूम एनालिसिस इज व्हाट आई एम डूइंग हियर, नॉट द सेम थिंग दैट मोल एनालिसिस के थ्रू नहीं जाना है आपको. तो व्हाट विल यू से, 44 grams of propane gives me 3 into 22.4 liters of CO2. समझ में आया? 44 grams of propane gives me 3 into 22.4 liters of CO2. Then what will my 13.2 gram give? ठीक है, वॉल्यूम ऑफ CO2 जो कि क्वेश्चन मार्क है. क्रॉस मल्टीप्लाई यू विल गेट वॉल्यूम ऑफ CO2 इज इक्वल टू 13.2 into 3 into 22.4 divided by 44. तो ये आएगा 44 और इसके बीच में 0.3 है, तो 0.3 into 3 into 22.4 which is again 20.16 लीटर. तो मास वॉल्यूम एनालिसिस भी आप कर सकते हो, मास एनालिसिस भी आप कर सकते हो. आई प्रिफर मोल एनालिसिस बिकॉज एक इंस्टेंट में सबके नंबर ऑफ मोल्स मिल जाएंगे, फिर वेट वॉल्यूम जो निकालना होगा निकाल लेंगे, राइट? सो आई होप you understood what we did today. Attempt as many questions as possible, get as many examples as possible. Solved examples पहले attempt करो ताकि आपके पास solution तो रहे, आप अपनी तरफ से attempt करो, then look at the solution if you can't get your answer, and keep attempting questions. In the next class, in the next session, we are going to look at this topic called limiting reagent. ठीक है, limiting reagent, what is it? Basically आपके पास जब तक substances के ratio जितना required है उतना है, so all the substances will get consumed simultaneously and the reaction will go to completion. But other way around, if one of the substances is relatively in lower quantity, reactants are in lower quantity, that will get over first and limit the extent of reaction or limit the extent of product formation. Such a substance is what we call as limiting reagent. In the next class, we'll see how to handle questions related to limiting reagent, right? So best of luck, students. See you.